What is up? Daniel here with the Virtual Robotics Studio, and we are back this time to do teleoperated code or driver control mode for the robot. So we're going to get started with that, but before we do, let's give another special thanks to Argosy for making this all possible, to First and Andymark for parts and support, and to Team 302, Lake Orion High School, for hosting our studio. Okay, so we did autonomous mode in the last video. That's the first 15 seconds of the match where everything is pre-programmed. Then we have another 2 minutes and 15 seconds where the drivers get to drive. And you can set up how your robot works kind of any way you want, but you're allowed 2 drivers. So a lot of teams will have one driver that just drives the base around and gets it into the right position, and then they'll use a second driver to kind of do everything else. In this case, there's not a lot else that we want to do. It's basically just spitting out the roller at the right time. So you might be able to put all of this on one gamepad. So you just have one driver controlling everything, or you can have 2 where the functions are split. Now, the reason why you might want 2 is if you are adding to this robot, so you're starting with what we have as the kitbot, but maybe you're adding something that lets you hang, or maybe you're adding another mechanism to be able to clear out the inflated balls, the algae, or something like that, or deliver that. You might have a lot of extra buttons and controls to do, and at some point it gets to be too much for the driver unless lots of things are automated. So I'll kind of show you how you would put the controls all on one gamepad, and then we'll also show you how to put them on 2 different gamepads. It's pretty simple, and it's like changing one number in the code, so not a big deal. All right, our first step, though, is to open our program back up. And so if you open up 2025 WPI Live VS Code again, it should still have your code from the autonomous video in there and loaded. So you can see when I opened it, it goes right back to the folder that was already there. But I will show you, if you close this, you do have the option to do File, and you can close the entire folder. And now there's nothing open. So if you are in this situation, or you copied the whole code folder and put it on a different computer, and you want to open it up on that computer, you want to choose File, Open Folder, and then you browse to the folder. So mine was on the desktop, and then in 2025 kitbot, FRC code, and then 2025 kitbot. Once you're in the folder, you can say Select Folder, and then that's going to open everything back up to where you were. Also, if you want to back up your code, like at this point we have working autonomous code or something like that. Maybe you just finished an event and your code was working, but you're going to make a bunch of changes to it. You can make backups to your code pretty easily by just copying that folder and renaming it. So like I have inside 2025 code, I have the 2025 kitbot. If I drag this and make a copy here, I can now rename this one as this is after auto video. And you can put a date on there or something like that. So now I have a backup. So if something goes catastrophically wrong in the future, I can look back and say, OK, well, this is the version of code that worked. So I can go back to that version and then try to rebuild whatever changes didn't work. So that's worth doing. There are some different software or websites out there that allow you to do source control or version control. One of them is called GitHub, which is what the professional version would be of doing this. If you're familiar with that, it's definitely better. You can use it. You can see when changes were made. Multiple people can make changes. That's definitely going to be more powerful. But also, there's a learning curve to learning how to use it. And if you're just making a few changes here and there, saving a backup at the end of every meeting or something like that when you've done coding is going to be probably good enough for you. So let's jump back into the code, though. We've got that backup made. We've got the code open. And what we're going to be working on now is in the teleoperated area. So we have teleop init, which, if you remember, runs one time at the very start of teleoperated mode. And then we have teleop periodic, which is going to be the part that runs over and over and over again. And that's where most of our code is going to end up. But we have to go all the way up to the very top first, and we have to do another import. So we want the ability to use gamepads. So for example, we in the code already needed to use Spark Max Speed controllers. So we had to include Spark Max Speed controllers. We wanted to use a timer, so we had to import a timer. We wanted to use differential drive, so we had to import a differential drive. Well, now we have to go in and we have to import the gamepads that we're using. If you're using either the Logitech gamepads that came in the kit of parts, which is what we're going to use here, or you're using Xbox controllers, the best way to do this is to do import, and it's going to be edu.wpi.first.wpi-libj again, dot. And in this case, we're going to go for an Xbox controller. If you're using a different kind of controller that is not an Xbox controller, you can still use this. All this is going to do is make it so that when you press the A button, it is the A button. If you use this and you're using a different controller, you're going to have to find out, like if you're using a PlayStation controller, like is the A button the square or the X or what is it? There is also another import that you can use that gets you raw values from the gamepad, and that can work as well. But I like using this one, especially if you're using the gamepads that were included in the kit of parts. All right, so we've got that set up. Now we have to come down to this area where we are making all of the, basically this lets us use gamepads or Xbox controllers. Then down here, we're going to create the specific ones that we're going to use. So we're going to do another private final. And I'm just underneath where we did that roller eject value. But really, right, this line can go anywhere mixed in here. I'm just kind of going at the bottom, though. And we're going to be creating a new Xbox controller. Then we get to name it. And you can choose whatever name you want for this. You can call it Gamepad 1, Controller 1, whatever makes the most sense for you. You can also do like this is the drive controller, and then you could have the roller controller. I'm going to go with Gamepad 1. Okay, and this is just a name, so we're not going to autocomplete that. We're creating our own name, and that is going to be equal to a new Xbox controller. And this one's going to be in, I guess, actually, so port 0 is the first port. So I guess if we want things to match, let's go ahead and make this one be port 0, Gamepad 0 in port 0. And if we're going to do two gamepads or two controllers, we can do the same line of code again to make a second one, Xbox controller, and then Gamepad 1 equals new Xbox controller import 1. So 0 and 1 is going to be also the ports, just to not confuse things. But again, like you could have this one be Gamepad driver, and the other one could be Gamepad operator, and that would be fine too. Usually that's what teams call the second driver, who's not doing the actual drivetrain of the robot. You have a driver and you have an operator. So if that makes sense to you, name it that way, and then just stay consistent in the rest of your program. All right. Then let's go all the way down now to the Teleop. Let's see, where is it? Teleop periodic. I don't think we have anything that we need to do in Teleop init right now, so we're just going to jump right into periodic. Make sure you get in between the two curly braces and then hit enter. And we're just going to set up the drive in here right now and see how that works. So there are a couple different ways that we talked about that the drive can work. One way is the tank mode. So we did differential drive tank mode when we were controlling it in autonomous mode, and that lets us control the left motor and the right motor separately. And then there is arcade mode, which lets us sort of combine the two together. And we'll do an example of both. We'll set it up working both ways, and then you can pick the one that you prefer. So the first thing we're going to do is control our drivetrain. And if you remember, when we want to control the drivetrain, we got to start with the name of it. So like in auto mode, when we wanted to control it, we went with mydrive dot, because that's what we called our specific drive for this robot. So mydrive dot. And then we're going to let's start with tank drive, because that's the one we've been using. And what tank drive wants is, again, a left motor power and a right side power. And in autonomous mode, right, we could just put numbers. We'd be like, oh, you want to go full speed? Let's just put a 1 in there. If you want to go half speed, put a 0.5. But now we can't just put a number in there, because that would be the number that our robot is moving at for the entire of driver control mode. Instead, we want to pick a number based on the gamepad values. So on the gamepad, there are a few different things that we can talk about. There are the joysticks, which is what we're going to use to control stuff. These also might be referred to as axes in the program, or in the driver station. I'll show you where that is. And then we have all of our buttons as well. So for the joysticks, which is what we're going to use right now, or the axes, the left joystick and the right joystick are two separate things. We have the y-axis, or the get y value for the joystick, which is going up and down on it. So this would be left y, this would be right y. And then we have side to side, so this would be left x, and this would be right x. Now for tank drive, usually what you do is you make the left y, so left forward and backwards is going to control the left side of the drivetrain, and right forward and backwards will control the right side of the drivetrain. So ultimately, if we push both of them forward together, that's going to make the robot move forward. If they both go backwards, the robot's going to go backwards. And to turn, you can go forwards on one and backwards on the other. And let's talk about values that we're getting here. So we can read buttons to see if they're pressed or not. They're basically a Boolean thing. Is it pressed, true or false? For the joysticks, we get a number. If they're not touched, they're going to send a 0. If you push them all the way in one direction, you're going to get a 1. If you push them all the way in the other direction, you're going to get a -1. And if you push it part way, you'll get whatever percentage you are at between the 0 and the 1, which is perfect, right? Because our motors want a value between -1 and 1. And our joysticks give us a number between -1 and 1. So we can just take that number, send it right to the motors, and the motors are going to work out fine. There is one problem that I think we're going to find, which is that I think forward on the joystick is actually a negative number, and backwards on the joystick is a positive number. So we probably are going to have to flip the sign. But we'll test it, and we'll see if that happens. All right, so in the code, now what we need to do is read in the value from our gamepad. So instead of putting just like, whatever, the number here like we did before, we're going to, and I think this was also something weird. Let me get rid of these two. Had like weird things. OK, so you start with the name of the controller that you want to use, or the item that you want to use, which was gamepad 0. I'm going to say gamepad 0 for me is the driver controller. And you do a dot. And you can see these are all of the different things on the gamepad that we can read in. So we have like, get right x, get right y, get axis. Well, let's see. Is the A button pressed? Is the A button released? Is the B button, or what is the B button value? And so on. So we have all of these different things, basically everything on the gamepad that we can read in. And we want to start with the left power. So we're going to do get left y, because y-axis is forward and backwards. So get left y. And then on the other side, we're going to do gamepad 0 again, dot get. This time it's going to be right y. Again, because y's are forward and backwards, and that makes, I think, the most sense. But of course, if you wanted to use something different, yeah, you could. OK, so this should take values from the left joystick and the right joystick going forward and backwards and send them directly to the left side of the drivetrain and the right side of the drivetrain. I actually think we're ready to test this. So make sure you have turned your robot on. I did not do that yet. So it's going to take, about a minute for it to boot up. And remember also that in order to actually connect to and download code to the robot, you have to be connected to the robot's wireless network. So that's what we're watching on the computer now, is when is that going to show up. Remember, it was like FRC, team number, and then you had the optional suffix that you could put on the end, and I think mine was high. So we're just waiting for that wireless network to pop up. And once it is working and we run it, we're going to be looking for a couple of specific things here. It is really tempting to have it like, OK, it's running, and just jump right in and be going like, OK, I'm driving. And that is OK, but at some point you have to stop and you have to test each function individually. So I'm going to just do one joystick at a time. I'm going to look at the robot, figure out which motor should move, and then move the joystick and see if it does what I expect. If it doesn't, then we're going to go in and try to figure out what we have to change to make it work correctly. And it's hard to do that if you're sort of moving everything at once. So the best way to figure out like what the left side drive is doing is to only do the left side drive individually at the start. And then we'll do the right drive individually afterwards. And then once we know what's going on, we'll be able to go in and make changes if we need to make changes. So definitely take one of your gamepads, go ahead and plug that into a USB port on your computer. just to help you keep things straight, I've got some red tape, and me keep it straight. I've red tape on this one. Controller 0 for me, or the driver, is going to have the red tape on it. And then when we hook up controller 1, that's going to have no red tape. All right, and it looks like my wireless network is up. So because I chose connect automatically, I am now connected to it. No internet, we are secured. That looks good. So now we can click on the WPI icon, and once again, we're going to choose deploy robot code. Remember, you can start typing in deploy if it's not, showing up on your quick start list there. And this is going to build and send it to the robot. So we'll just wait for that to finish. And once that's done, we should get that extra window popping up here. OK, that's cool. I think now we have to run our driver station software. So, I don't know when that ran. So run your FRC driver station and say yes. And there's a few things we're going to do with this before we enable. The first thing, though, is make sure you're on teleoperated mode. We were doing autonomous yesterday, or in the last video. So make sure you're in teleoperated, not autonomous, because if you enable it in autonomous, it's going to do the autonomous mode, which, depending on which one you have selected up here, could do all kinds of different things. All right, so I'm on teleop. The next place we want to go to is the USB tab down here. It's the fourth one down. And you'll see that I have a controller here in port 0 because I only have one controller plugged in. I'm going to go ahead and plug the second controller in now, just to show you what that's going to look like. So when you have the second one plugged in, now I have a 0 and a 1. And sometimes it can be hard to tell because we have two identical controllers. They're both gamepad F310s. How do you know which one is which? Well, if I take one of the gamepads, I'm going to do the what I want to be gamepad 0, the one with the red tape. And if I start pushing the buttons on it, we should see something respond here. So on the driver station, I'm on gamepad 0. And if I start pressing the buttons, you can see they're over here lighting up. So that's like A, X, Y, B. I can do the bumpers on the side. Also, if I move the joysticks around, you can see these dials are going to move to match that. And these are the different axes. And you can see now, if I put my mouse kind of, I don't know if I'm off on the side, I'm not on top of them, you can see that the first one is labeled 0, left X. The second one is labeled 1, left Y axis, and so on. Then 2 is left trigger, 3 is right trigger, 4 is right X, and 5 is right Y. When I talked about that get raw values, you can get the raw values from the joystick. In this case, if you wanted to do left Y, you'd be looking for 1, axis 1 on the joystick, because that's left Y. And then we would want axis 5, because that's right Y. And you can also figure out the buttons, because I think this is button 0. I think it starts at 0, but I might be off by 1. So it looks like A is button 0, and B is button 1, and so on. So if you're using a different controller, that's how you can find out which button is which. And if I click on gamepad 1 and I start pressing the buttons, you can see nothing lights up over here and nothing moves, but the gamepad itself, 0, is lighting up on this area here. So you can tell that I'm highlighted on the wrong one, and the buttons I'm pressing are part of gamepad 0. Then if I do the same thing, press buttons on gamepad 1, now it's lighting up on gamepad 1. So that's how you can keep them straight. Now, let's say you plug them in, and the one that has the red tape that I want to be gamepad 0 is showing up as gamepad 1 in the USB order here. So I can show you how that would look. If you click on one, you can actually just drag it to whatever spot you want. So in this case now, I have gamepad, this one should be 0, the driver one, and I'm pressing the buttons on it, and you can see that is now in the gamepad 1 position, which I don't want. So again, I can just left click and drag that up to gamepad 0, and now we're back at gamepad 0 where we want to be. Okay, these things can get changed, so you got to keep an eye on that. In theory, if you plug back into the same USB ports every time, you should be okay. But I've definitely had instances where teams have gone out and flipped the gamepads, basically. It got switched in that USB order, so they were trying to control the drive, but it was moving their arm or something like that, or they were trying to move the arm and the robot was driving around. So keep an eye on that, especially when you go out to a match. My team's pre-match ritual was always to go to this tab, hit buttons on one gamepad, make sure the right one's lighting up, then hit buttons on the other one, make sure it's lighting up, and then we were ready, for the match, amongst other things, picking your auto mode and all that stuff as well. All right, so that is looking good. Let's go back to the first tab now. Again, make sure you're on teleoperated, and we can go ahead and enable. And when we enable, we should be able to drive the robot now. But like I said, I'm not just going to go crazy on the joysticks. I'm going to say, OK, just the left joystick, and I'm just going to push the left joystick forward. And when that happens, what I expect here is the left side of the robot to move that way. Let's see what happens when I go slowly forward on the left joystick. And I'm not going to go full speed at the start, right? Slow is good enough. All right, so that is the left side that's moving, but it is moving backwards, not forwards. And that's what I said. I think the joystick axes are opposite of what we would expect. All right, let's try the right joystick and see if it's doing the same thing. So right joystick forward is making the right side move, but it is also backwards. Okay, so if I do both of them forward together, it should drive. Well, now we expect it to drive straight backwards because we know it's backwards. And I think that might have been me. Hold on. Let's go again. There we go. OK. So some of this, too, is like you have to control the joysticks the same amount on both sides to make it drive straight. Like if I push one farther than the other, it's going to turn a little bit. And I think because everything's backwards, when I see it turning one way and I try to compensate, I make it worse instead of better. So let's not mess around with this and teach our brain bad habits. Let's fix it before we drive around anymore. So I'm going to go ahead and disable the robot. And then we'll go back to our code. And the easiest way to flip this is to just do negative gamepad 0.left y and negative gamepad 0.get right y. So that's basically saying multiply it by -1. Now, I know we talked about in autonomous how we want to reverse the motor. So a positive value is a positive value. And that is definitely true when you're looking at especially raw numbers like that. There is no easy way to flip it and have it be right in autonomous mode and have the gamepads match up as well. So we go with this negative because it's sort of the simplest solution. You could do a thing where you make, where you read in the value of the gamepad and you multiply by -1 before you get here. But I don't think it's worth it. I think this is the best way to fix the problem. All right, so now both of them are backwards. We flipped both of them. Let's go ahead and deploy our robot code again. And while this is going, I'm going to spin the robot back around just so we can start in the same orientation as last time. OK, code looks good. Let's get that driver station back up. And teleoperated and enabled. OK, so now let's try that left joystick again. Left joystick forward. I expect the left side to go forward. OK, that's, yep. And now right side forward. Yep. So both of them forward together, we should drive straight forward. And both of them backwards together, we should drive straight backwards. Well, straight-ish backwards. So this, if you're messing around with this as well, and then let's do turning first. So right forward, left backwards, I can definitely turn in place. Now this robot, it zips a little bit. It's pretty fast. When you're doing this stuff. Now, fast is good, assuming you have had enough practice to control it. But there are a couple of issues that we're seeing here, that I'm seeing. And that is when I try to drive slowly forward. Let's say you're almost in position and you're just trying to perfectly line up for something. Well, I want to drive. I don't want to turn at all in this point. Let's say I need to drive just forward like a foot to be lined up to score the game piece. Well, going slowly forward on both joysticks, it's really hard, like it's already turning. It's really hard to be able to drive straight forward right away. Even backing up there, I'm trying to go straight, And I can kind of do it with lots of experience, but there's a little bit of curving there. So one of the downsides to this tank controls that we're using right now is that your driver needs to have a lot of skill when they're doing that small movements forward and backwards, and you want to not turn, because you got to basically push the joysticks forward the right amount, and you have to adjust how much you're pushing the joysticks to keep it straight. Arcade mode doesn't have that problem, but there are some good parts about tank mode too. For a lot of people, it is intuitive to know what's happening on the robot by controlling the joysticks like this. And also, like, there are a variety of vehicles that somebody might have driven that drives in that manner. Let's try arcade though now, and you can kind of see what you prefer. So let me disable the robot, and we'll talk about what is arcade. So arcade is more similar to if you're playing like a first-person video game on a console. That is going to be more similar to the controls that we have for arcade. So for arcade, and I guess for those games, right, if you were playing a game on console, like say the left joystick, it would be forwards, the whole person would move forwards, the whole person would move backwards, and then left and right, it would actually usually be like strafe left or sidestep left and right. We're not going to use that. We just have forwards and backwards, everything together. And then the other joystick would be used to like aim. So if you turned a little bit, that would change where you're aiming. That would basically be turning your character. And then if you were pressing forward, it would walk in that new direction. So in this case, arcade, we're going to have forward and backwards, which makes the robot move forward and backwards, both sides together. And then the right joystick, left and right, will make the robot rotate left and right. This is probably going to be the one that you want to use. I prefer this for driving the robot, and most people who have played a lot of video games prefer this because that is what they're more used to. So let's go ahead and swap it over to that. You can try both. You can choose the one you want. Again, it just depends on whoever your driver is and what they prefer. So let's go into our code here. We have our tank drive line. I don't want to get rid of this line of code. I want to save it. So I'm going to do 2 forward slashes to comment this out. And I'll put another pair of forward slashes above it and says maybe like uncomment this line or the line below if you want tank drive tank style controls. That sounds good. OK, then we can do a new line. And I'll do uncomment the line below if you want arcade style controls. And now we got to do the actual line of code. So we start again with the thing we want to control, which is my drive dot arcade drive this time. And in arcade drive, now it wants double X speed and double Z rotation. So I promise you X speed is the forward and backwards of the robot, and Z rotation is the rotation on the robot. So again, we got random things filled in here. I don't want them. We're going to get rid of both of these. And we're going to read in the values from our gamepad instead. So it's going to be gamepad 0, because that is the driver gamepad for us. Dot. And forward and backwards on the robot should still be get left Y. So get left Y. And we already know from testing on the last one, this get left Y is going to need to be a negative value of it, so because it is backwards. So we're going to do negative gamepad 0 dot get left Y. Now the other side is going to be gamepad 0 dot get, and this time it's going to be right X. And make sure you're auto-completing or getting the caps correctly, the capitalization correctly. So this is going to read in the value on our right stick, x-axis, left and right axis. Now, if you prefer, you can do left X as well and put everything all just on the one joystick and not have to use both. I prefer having them split because it's a little bit easier to not worry about, like, if you're pushing the left stick forward and backwards, if you go slightly on a diagonal, that would make the robot start turning. So having them split, I think it's easier to not accidentally do stuff. But again, it's preference. If you like them all on one joystick, then use get left X instead of get right X. OK, and I think there's a chance that get right X is also backwards. But let's go ahead and run the code this way and find out. And then if it is backwards, we can go back and change it. So hit your WPI Live icon, do deploy robot code. Also, by the way, like Shift F5 is the shortcut for deploy robot code. We do it a lot. So if you learn that shortcut, you could probably save yourself a little bit of time. But choose deploy robot code. And we'll let that do its thing. 9 seconds. All right, gonna close down this window, open up our driver station. And once again, before I enable it, I'm gonna think about what I expect to happen and see if it matches my expectations, so we'll know it's correct that way. So if I push the left joystick forward, I expect the entire robot to drive forward. If I go backwards on the left joystick, I expect the whole robot to drive backwards. If I go right on the right joystick, I expect the robot to turn to its right or turn clockwise when viewed from above. And if I go left, it should turn the other way. All right, so let's test those 4 things. Teleoperated mode, let's enable. OK, and then here we go. So left joystick forward, I expect the robot to drive forward away from me. Yeah, that's good. Backwards, I expect it to drive backwards towards me. And here you can already see what I was talking about. If I need to drive forward like 1 foot straight forward without turning at all, well, I can do it so much easier just because both of the motors are getting the same amount of power. I don't have to feather the joysticks to keep that controlled. All right, so those both work fine. Forward and backwards, great. Left joystick is working the way we want it to work. Now let's try the right joystick. I'm going to turn to the right. So I expect the robot to turn this way. OK, that's backwards. And let's try to the left just to make sure it actually works. OK, so the right joystick is also inverted. So let's go ahead and disable, go back to the code, and let's make that change. So we are disabled, and it means we need a negative for gamepad get right X as well. All right, let's deploy it. Shift F5 or click the button and choose deploy robot code. And I'll close this window down, enable the robot, and one more time. Let's try turning right on the right stick. And now it turns right. OK, so now we can also combine the two. So I can be driving forward and turning left at the same time. And that will take it in some kind of arc. Depending on how much I go on one versus the other, we can control what that arc is. Still jumps around a lot, though. So there's something else that we're going to do here, which is like, yes, if you go fast on this joystick, it's going to take off. I wonder if we can make the coral piece fall out on accident. We can. OK, we learned something. That was interesting. I'm not sure that we want to do anything mechanically to stop that, but your driver should definitely be aware that going full speed backwards to full speed forwards is a bad decision when you have a coral piece inside the robot. All right. So the fact that this moves so fast is both good and bad. It's good because you only have 2 minutes and 15 seconds, and that is a short period of time for you to score as many game pieces as possible, which means any time wasted driving back and forth between the two places is going to be a problem for you. That is going to basically mean like if it takes you 20 seconds to get a piece and score it when you're driving fast, but it takes you 45 seconds to do it driving slow or 40 seconds to do it driving slow, you're going to score half as many pieces, right? So obviously anywhere we can minimize time, the better. But the flip side is a lot of your time is not actually spent driving from like the human station where you're loading and the goal, the reef where you're scoring. A lot of it can be lost lining up because when you get to the human player station, you have to be lined up in a certain way to make sure the piece drops into the robot. When you go to score it, you have to make sure you're in a very good position there. And if you're trying to do that and the robot is like jumping on you, like if I'm pulling up to the line and I'm hitting stuff and the robot is way overturning and I don't quite have the touch on the gamepad yet, that's going to cost you more time than just driving slower. But instead of making the robot slower by changing the gear ratio or by rebuilding it, we can do something in software where maybe at some times you want to go into a slower mode where you have more control over the robot, and then you have the faster mode when you're driving far. So this is something that I like to add to robots, but it's something that you're going to use maybe a lot when you're just getting used to the robot. And the better your drivers get, the less they're going to use it. So the less important this is, the more driver practice you get. But let's take a look at how we could do that. If we look at this line of code, right, this value we said is between -1 and 1, and that's what's getting sent to the motor. Well, if we divided this number by 2, now instead of -1 to 1, it's a number from -0.5 to +0.5, which basically takes our entire range of speeds and scales it down by a factor of 2, divides it in half. So anytime we would have been going full speed, now we would be going half speed. But if we just put the divide by 2 in the code here, that is unchangeable. That's always going to be divided by 2. We can never get the fast speed back. But we can do it with a variable instead. So let's go all the way up to the top of our program here. And I like to put it next to our other kind of variable things. So I'm going to put it right underneath the roller eject value. Okay, and this one, we have to do it a little bit differently because, again, when we were doing in our code the private final, that means it can't change. But this is a variable that we need to be able to change the value. Sometimes we want to be dividing by 2. Sometimes we want to be dividing by 1. So we're not going to do the final. We just do private double. And then I'm going to call this drive speed. And we're going to do equals 1. So at this point, we can choose what value we want it to start at. And if you don't hit any of the buttons, let's have the robot be full speed. And then you can choose to slow it down for more control. OK, then we're going to scroll all the way back down to teleop, periodic. What if, instead of dividing by a number, I divided by drive speed? So right now it's a 1. But if I went back up to the top and I made drive speed 0.5, or 2, sorry, then it would divide by 2. We could also do drive speed as 1 and 0.5 and multiply it instead, whichever you prefer. So in this case, if drive speed is a 1, we're going full speed. If it's a 2, we're going half speed. And we want to do the same thing for the right x as well. So we're going to divide that by drive speed also. But then we have to do something before we get to this line of code that actually checks or lets us change what the drive speed is. So I'm going to go to the top here above all of our commented out stuff and start a new line of code. And what we can do is we can basically say, hey, if you're pressing a button on the gamepad, like, I don't know, if I'm driving and my thumbs are on the joysticks, I don't want to have to hit this section of buttons over here, because that thumb is busy controlling the robot. Like if I move here, I can't be turning at the same time that I'm hitting the button. But the buttons on the ends here, these are the top 2 are L1 and L2. I think they're on Xbox controllers. It's called left bumper and right bumper, and the bottom one is left trigger and right trigger. So if we use left bumper and right bumper, that is something that I can do while still using the joysticks. The other thing that you can do if you're comfortable with it is actually if you push down on the joysticks, they are actually, I think that's L2 and L3. I don't know what it's called in the program, but we can find it. So you can make it so pushing down on the joystick would change your speed as well. But I'm going to use the left bumper and the right bumper for this. And in my mind, right is full speed and left is half speed. But if it makes sense differently to you, then you can do it the other direction. It doesn't really make a difference. So in the code, basically what we want to say is, hey, if you're pressing the left bumper, we should make our drive speed 1/2 of what it was before, or 2, so we can divide by 2. And we start again by doing the name of the thing that we want to read from. So gamepad 0 dot get, and we're looking for left bumper, and we can kind of choose amongst these for which one we want to do. We can see if it's pressed, or we can see just the value of the bumper, or if it's released. In this case, I'm going to do get left bumper button. And it looks like left stick button would be that pushing down on the joystick if that's what you want to use. So this is going to basically be a true. The value of get left bumper button is going to be a true if the button's pressed. It's going to be a false if it's not pressed. And the way the if statement works is, if you remember from auto mode, we had like, if the timer is less than a number, then we run this code. But really what it's saying is so timer is less than the number, that's going to be either true or false. If it's true, then we run the code that's there. If it's false, then we don't run the code that's there. So it's the same thing here. If whatever is inside here is true, we run the code that is inside our, let's add a curly brace, an open curly brace. So if this is true, we run whatever is inside here. If this is false, we don't. We skip it. You can also, put equals true if you want. But since this is already going to be true or false, we don't have to check. So basically this is saying, hey, if the button is pressed, which is true, then we run this code. If the button is not pressed, then it's not true. It's not being pressed, then we don't run this code. And just a note about this, the equals, if you remember, like up at the top, when we just created this, we said it is equal to 1. When you use a single equal sign, that's like saying take this value and store it in this variable. If I did that down here in this code, if I just did a single equals, this line of code would be saying take the true value and store that in wherever gamepad0.getLeftBumper button is being saved. That's not what we want. We want to compare the two and see if they're equal. And so the code for that is double equal sign. So when you see double equals, it means you're comparing the things. If you see single equals, that means you're saving the value into it. And again, because this is true or false, we don't actually have to do the equals true. That's up to you. But it isn't going to hurt anything if you add that. OK, so again, if the left bumper is pressed, that's when we're going to run this code. That's when we want to go to half speed on the drive. And then later we'll say, OK, if you press the right bumper, go back up to full speed. So left bumper is pressed. That means now we're going to change our drive speed variable value to be equal to 2. So in this case, we're back down to the single equals because we want to take that number 2 and we want to shove it inside drive speed. And then if we look down here, when we divide by drive speed, that means we're going to be whatever our value was divided by 2. So we're half speed and half speed on the rotation. Half speed on the forward backwards, half speed on the rotation. But now we got to do the other one to make it work out as well. So we have a couple choices here. We could do this the same way we did the left bumper. So if you do the code, if the left bumper is pressed, go half speed, and if the right bumper is pressed, go full speed, that's going to work just fine, except weird things could happen if you press both of them at the same time. It's not obvious which one is going to run. I don't think that matters for us, but we do have the option in the code of doing just another if, like we did before, or we could do an else if. If you do an else if, only one of the two cases can ever run at the same time. But in this case, I think I'm going to do an if. And we're going to do gamepad0 again, .get, this time right bumper button. And then we can do the open and close curly brace. This time I won't add the equals true because, again, that's not necessary. Here, if it's pressed, it's true. If it's not pressed, it's false. Now, in this case, both of them can run if we press both buttons down. But this one runs first, which is the half speed. This one runs second, which is going to be set it back up to full speed. And that's what I want, I think. I think all things being equal, you want to go into high speed mode. So that's why I'm going to use the regular if. If we use the else if, then you would, if both buttons were pressed, you would default into the lower speed mode. So here we're going to set drive speed again, this time equal to 1. Because if you divide by 1, it's like doing nothing. All right, I think that's it. Let's go ahead and deploy our code again. Deploy robot code. And close this extra pop-up window, go to the driver station, and I am enabled. OK, so now it should be exactly the same as it was before. So let's see if I go, I'm going to bump the stick really far and see if it goes fast. Yep. That is still as quick as it was before. You can really see that in the turning. It turns very, very quickly. OK, let's try pressing the left bumper now. So left bumper should make it half speed. Left bumper. I'm going to push all the way forward. That is all the way. That is full speed. You can really see it when you're turning. And again, if you need to be lined up, like if we're trying to back up directly against, something, like if I'm trying to back up directly against this line back here in order for the human player to load it, if I get close and then each turn, let me go back to full speed by pressing the right bumper. If each turn was doing this to you and you're having a hard time getting perfectly flat, well, now we have the option of hitting the left bumper, having that slower rotation where I can very easily get it pretty much straight on. But like I said, as your drivers get more and more practice, they might be able to very quickly still do it at full speed. Here's the easiest way to tell that it's working. If I start spinning at full speed and hit the left bumper, it immediately drops down to that lower speed. If I hit the right bumper, and then left bumper again. So we know that that's working. Now we have the option to choose. Do you want the robot going super fast, or do you want it to be slowed down so maybe you have a little bit more control? And you can, I'm going to disable the robot. You can kind of make your choice, right? Do you want half speed? Maybe half speed is too slow. Maybe you just need like 70% speed. You can do that, right? So you can change your value here. Instead of dividing by 1 or by 2, you can change those numbers. Instead of dividing by 2, you could divide by 1.5, and then you would be a different speed. If you want to think about it in terms of percent, then you could change drive speed. You could change this down here to be times instead of divide by. And then to go half speed, you would do 0.5 for half speed, or if you wanted 70%, you could do 0.7. So that is also an option if you want to go with a different value there. But I'll leave it at the divide. I think the divide makes more sense for what's happening down here, but the multiply makes more sense for what's happening up here where we're choosing the numbers. OK, so that works. I think our drive is basically set. Again, you can choose if you want to switch to tank drive, but you want to keep the drive speed change. Make sure you add the divide by drive speed here and divide by drive speed here. So now both those lines are the same, except basically the only difference is get right Y or get right X. So that's, I guess, not too hard to change back and forth between them. All right, now we have to control the roller is our next problem. And there are a few different ways you can control the roller. We know from our autonomous that there is some value that you want to spin the roller out to be able to spit the coral out at the right speed that it drops down and stays on the reef, on the little shelf there that we're trying to score it on. If you're going too fast, it has the chance of like maybe bouncing off and coming out. And if you go too slow, it has a chance of maybe not actually leaving the robot. If you pick a number that's too small, it might just get stuck and not have enough power to actually spit the coral out. So we have to find somewhere in that sweet spot where stuff works. Which means when we go to score with this robot, when you're lined up and you're ready to score, you want to have one specific speed or one specific power that's going to that motor to be able to dump out the coral. But what if it gets stuck? What if for some reason that number that you chose worked at the start of the match, but things happened and I don't know, maybe the robot got bumped. Maybe we talked about there is the possibility that those bearings can fall out. Maybe something happened and things are now not aligned as well as they were before. And that power that we're using isn't enough to spit the coral out. You don't want to say, oh, well, too bad. This match is over. I guess we can't score anymore. You want to have some other way of also controlling this roller to be able to adjust your speed. So you have a few different options for how you want to do this. I'll do it the way that, again, First Code is doing it. But there are plenty of choices. One option is I'm going to be working on the second gamepad here. So let me... I guess if I need to pick it up, I need the cord unwound. OK, so you could just say, hey, look, this joystick right here, this gamepad, has nothing bound to it. The drive one has everything we've done so far. So on the drive one, right, we're using the 2 joysticks, and we're using the 2 bumper buttons. Well, we're using up and down and left and right on the joystick. On this one, nothing. It's a blank slate. We can do anything we want. So I could say, hey, this joystick up and down controls the roller. That would let me give it whatever power. I could choose the power forward or backwards to be able to make that roller move. And then I could also use buttons, separate buttons, to have it have different powers to spit it out. Really, we just need one power, which should be the power that works. But that is another, like you could have different options there as well. And then I think what first is doing is they have the two triggers on the back here that are controlling it as well. And the way that works is one trigger basically, OK, the triggers are not buttons. They are analog. They are axes. But they start at 0 when you're not pressing it. And then as you press it, it increases up to 1. 1 is pressed all the way. So they don't have backwards. So if you want to be able to control it with variable speed forward, you can have one trigger controlling variable speed forward. But then you need a second one that controls it for variable speed backwards. So you have kind of the two triggers working together to do the same thing that the one joystick would be doing, or left or right joystick, your choice. So you can choose which way you want this to work. I'll show you the joystick, and I'll also show you the way they're doing the triggers. But no matter what, we want to make it so if you are holding down, like let's say the A button, that should spit stuff out at a very specific speed. So that's our goal in this code. And we're going to be controlling stuff in a couple of different ways. We want to control the same motor, but with multiple different buttons. And you don't ever really want to have multiple sets to your motor in your code. Ideally, you only have one set in one place. And the reason is, so like if we look, if we have up in here where like, OK, we set the drive speed here, we could also set the drive speed here instead and here. Like we could take this line of code and we could put it in here, and then divide by 2. OK, I think, let me show you what I'm talking about, because that got confusing to me. So we could put this up here, and then we wouldn't need this drive speed variable. We would just know that if the left bumper was pressed, you could divide by 2. So as long as you were holding down the left bumper, you would be going half speed. But the problem is, if we put it also in here, and we didn't change it, we just had divide by nothing here, there is the chance that both this code and this code could run at the same time. Now, we could be very careful with how we construct our code. We could have done an else if here. We can try to make it so that it's unlikely for that to happen. But mistakes can happen. And so as a fail-safe, basically, if two different things are trying to control the motors at the same time, you have no idea what result you're going to get. It might flicker between the two values. It might flicker between the two values so fast that the motor stops working. You can get really weird bugs when you have multiple things controlling the same motor at the same time. So the best scenario is like we did here. Instead of putting multiple different drive things in multiple different places, we only have the single drive once at the very end. And that is the one that we are relying on to make stuff work. Also, I don't know why, but it added some extra curly brackets. OK, we're back. So we're going to kind of do the same thing when we try to control our roller. But let's just start with the very simple, let's just make the joystick control it and see how that works. So we would start with the roller motor. Roller motor. There it is. Dot. And we're just going to do dot set. And if we just want to control it with the gamepad, with the joystick on the gamepad, then let's do gamepad 1 dot, because again, 0 is for the driver, 1 is for our operator. So we're going to use the second gamepad here. And gamepad 1 dot, let's get, I like left Y, I think, for this. Get left Y. And I think we're ready to test that. So that might be backwards, that might not be backwards. But we're going to deploy the robot code and find out. It depends on the motors on which side. I think it's probably backwards, to be honest with you. But let's find out. All right, close this. Enable in Teleop. And now I've got that second controller, the one without the red tape. And left joystick should control the rollers. So if I push forward on the rollers, they definitely go backwards. And so it is backwards. We need the negative sign. But if I go backwards, it should spit out the coral at some point. And I can sort of choose the speed, right? I can make it spin slowly or fast. So you have you have basically at this point what we would consider full manual control of the roller. We can give it any value. We can make sure that if something is stuck there, if the coil's jammed in at a weird angle, we can run it backwards to try to suck it back in and get it to line back up so it can maybe spit out cleanly. If it's getting stuck, if something's a little bent and it won't go out with the low speed, we can just keep increasing the speed until it has enough power to spit it out. So you want some kind of manual control like that. That works with the gamepad. Let me go ahead and disable, and then we will now start building kind of our different way of doing this. So the problem is, I also want, and I'll go above this line of code, I also want at some point to be able to make the button control the power. So we're going to have to basically check the button and make some decisions based on that. So we're going to start with an if here. So we'll do if, and gamepad1 dot get, and let's use the A button. So this is basically like if the A button is pressed, then we run the code inside of these curly braces. And what I was saying is, like, it's tempting to just say, hey, roller motor dot set, and this should be our roller. Wait, I forgot what it was. Let's scroll up to the top. Our roller eject value. Right, so remember we made that variable, so if that number changes on you, you only have to change it in one place. So roller eject value. Like, this is kind of what we want the code to be, but the problem is now we have this other line of code down here that is doing that's doing kind of the same thing. You can kind of save this if you do an else case and put that inside of this else. Right, because we know that only this code or this code could run. So that is one way to do it. But we're going to run into a problem doing it that way because well, maybe not. Actually, this is probably okay. I think it's slightly better if we use an intermediate variable for this instead. But this way would work as long as you're careful, right? As long as you're sure that you always have it in an if and an else, and there's nothing else in other places. But I think it is better practice to not do it this way. So instead, what we want to do is we want to say at the very bottom is where we want to have our roller.set. So we can put that in. So roller motor.set should be here. And what we put inside it, I don't know yet. But we want to then change these two roller motor.sets, this one in the get A button and this one in the if the A button is not pressed, to something else. We want to save the value there, but we want to save it as another variable. So kind of just like we did drive speed, if we have a drive speed variable but it's a roller out variable, then we can save that roller out variable in these two places, and then we can put it in here for the set. So let's do that. Let's go all the way up to the top. OK, not quite the top, but let's go to where we did drive speed. And let's do another private double. And this one I'm going to call, like, I think I said roller out. I like that. This is our roller output. And we're going to do equals 0 to start with. So the roller should start turned off by default. I think that makes the most sense. OK, and then we can go all the way back down to our teleop periodic. And our final roller.set then is going to use the value of roller out. Starts at 0, we have to do something to change it. Now, up here, if the A button is pressed, we're not going to set the roller value anymore, the motor value anymore. Instead, we're going to set roller out, our variable, to equal our roller, I think if I do capital, it shows up. There we go, eject value. So now if the A button is pressed, we're taking that value and saving it in roller out. Then when we get down here, that's the value that's going to be sent. Now, if we're not pressing the A button, then we want to control it a different way. And in this case, instead of roller.set, we're going to control it by, and you can leave your gamepad 1.getLeftY if you like that, but we're just going to say roller out equals that value. And we said that value was backwards, so let's go ahead and add our negative now. So what this should do then is it should say if the A button is pressed, if you're holding the A button down, we eject at our specific ejection speed, our good scoring speed. Otherwise, it's just whatever the gamepad is doing, which means if we're not touching the gamepad, it'll stop. If we're pushing the gamepad to some value, it'll save that value, and then that value, when we jump down to the last line of code, our roller motor.set, that value will get sent to the motor. So what we're doing basically is the same thing as doing set here and set here the way we had it before, but this is kind of like the safer, more correct way to do it to avoid any mistakes. Okay, let's try this, and then I will show you an alternative way to control the rollers with those two triggers, and that will match up with the way that first code is set to run. Their default code is set to run. So we're going to deploy. Let me go get those. Get the coral back. And I guess we have the ability to drive the robot too, so I can make it drive over here once we are connected. All right, we're good. I'm going to go to the driver station, enable Teleop. And I guess the first thing I'm going to do is drive the robot over here. So we'll turn it a little bit, and I think I want to go slow when I'm driving at myself. All right, we can drive over here. I'll load a coral piece in. And then I guess, let me turn it around so when it spits the coral out, it's like I'm going to be able to catch it. That looks good. All right, so now on the second gamepad, the first thing is if I press the A button, it should spit the coral out at a good speed to land and stay on the shelf. So I'm going to hit the A button, and it definitely went out. That might be a little fast. I don't know. It's going to be hard to tell. We're going to have to do some other testing to figure that out. All right. And then next, I can use the gamepad again to try to control it. So you can see if I'm not touching anything, it stops. If I use the joystick, I can go backwards or forwards on the coral. And then at any time, even if I'm going, let's say I'm going backwards to try to keep the coral in or reset the coral, I can still at any time press the A button, and the A button will overwrite this and spit it out. OK, that is working exactly the way we want it. Let's drop that coral piece back in there. All right. So that is one option. If you like the joystick as your manual override control, that works. If not, let me show you an alternative. This is the way I think First has it set in their program, their default program. So disable the robot, and then I'm going to comment out this line of code that we just did. And I guess I'll leave a note above it, like uncomment the line below if you want left stick Y to manually control the roller. And then below that, we're going to do, I guess I'll do the same note here, uncomment. It's got to be capital. Uncomment the line below if you want the triggers to control to manually, why did I capitalize that one? All right, manually control the roller. All right, so we have our two options here. Now this one is a little bit more kind of confusing in the sense that we need to take two values. We need to take the value from the left trigger and the right trigger and combine them. And if you remember what I said, the right trigger, both triggers are 0 when you're not pressing them and 1 when you press it all the way. We want one of these to be positive and one of these to be negative. So if we basically subtract one from the other, like if we take right as positive, left as negative, and we subtract the left value from the right value. If you're not pressing anything, it's 0 and 0, great. If you're pressing just the right one full power, that's going to be 1, and this is 0, so 1 minus 0 would be 1, so we'd be going full power forwards. If we just pull the left trigger all the way, that would be 0 minus 1. That would give us the -1 to spit it out. And then the weird part, though, is like if you're pressing both at the same time, you'll get some weird, who knows what it's going to be. If I press this one a little and this one a little more, it's going to give you some weird speed. So the way this is meant to be used is just do one trigger the amount that you need, right? So if you want it to spit out, then you should just be doing the right trigger, and you can pull it as much as you need to pull it. If you want to maybe unjam or suck the thing back in because it started falling out, then you would do the left trigger just as much as you need. If you do both of them together, it's still going to give you an output. It's still going to do something. It's not going to break anything, but it's going to be less predictable or less controllable than doing them one at a time. So that's how we're going to set this up. So in this case, we have our roller out variable. Roller out is equal to, and remember that roller out, whatever we set that to, that is the actual value that goes to our motor. And that's just going to be equal to, gamepad 1 dot get left trigger axis. I guess we want right trigger axis. Right trigger axis minus gamepad 1 dot get left trigger axis and semicolon. So this is what I said. If you're not touching one of them, then it's just a 0. Right trigger is going to start at 0 and count up to 1. Left trigger then, because it's negative here, is going to start at 0, and essentially when it goes up to 1, it's going to count down to -1. So that should give us the same control. And let's go deploy this, and then I'll keep talking so it can deploy while we're talking about stuff. OK, so why use the 2 triggers? I don't know. Maybe you feel like you have more fine control on the trigger. Maybe you prefer that just based on how you like to use the controller, right? But I think the joystick is probably better or more controllable if you have one person whose whole job it is to control this. But imagine you've decided to go with only one driver. So you have one driver that's out there, and they are going to basically park and then hit the button to spit the thing out. For them to be able to do extra controls, well, we already kind of used up the gamepads. We don't want to put anything else on the joysticks. So that's why I think using these triggers could make sense. So I like the triggers if you're doing it for one driver, but I do like the joystick better if you're doing it for 2 drivers. All right, I think we are deployed. So let's go ahead and close that real log window, and let's enable the robot. All right, and let's see if that works. So once again, if I hit the joystick now, it does nothing because we took that out. If I hit the A button, it should still spit the coral out at our given speed. It's 0.44 right now, but you might need to change that. OK, yep. And then if I do the left joystick, or the left trigger, sorry, I should be able to make it spin backwards at variable speed. So slow and fast, yep. And if I do the right one, I should be able to make it go forwards at variable speeds. So slow, you can see if the value is too small, like what I'm trying to do here, it starts going, but it kind of can't spit it out until you get to a certain amount of power. But then, of course, yes, we can go full power. And the danger with full power is, you can see how much it spit out and bounce. There's a good chance that that hits the shelf, bounces back, and doesn't stay inside the robot. So it's nice to have variable control, even if you have to go to your manual override, your manual backup. All right. That looks like all of the code we really need to add to the robot. There's kind of one more test that I recommend doing before you get to a field if you don't have easy access to a field. And that is, we want to find some way to kind of try to tune in that value of, which is 0.44 right now, our roller, what do we call it? Our roller eject value of 0.44. And if you're able to, there are directions that first sent out for at-home practice components. They're made out of wood. If you can, it would be great to build the shelf or some piece of that reef shelf. I know that's a really, really big piece. But being able to tune that in and practice scoring on that is going to be very helpful for you. If you have some skills with just woodworking, if you even didn't make the entire hexagon shape, if you just had one little square section that was the right height with the right angle of the floor and the right lip on the front, I think it's 18 inches to the top of the lip, but then you need to get that angle. You could just build that section and use that to practice with as well. But I would also really recommend, if at all possible, ask around. There's probably a team somewhere near you that has those practice field elements built that you can go and you can borrow. And that's what we're going to do in the next video. We're going to visit Team 302's practice field, take this robot out there, try to tune in some values, test our auto modes, and get some driver practice. That's going to be the next video. But before we finish this one, let's give another special thanks to Argosy for making this all possible, to First and Andymark for parts and support, and to Team 302, Lake Orion High School, for hosting our studio.